مرحبا فيكم جميعا. أنا الدكتور محمد أسامة الرشدان من قسم الطب النفسي. بدنا نحكي اليوم عن موضوع الذاكرة. The title of today's lecture is memory. The slides were prepared by Dr. Radwan Bani Mustafa, who is the other consultant psychiatrist. Today I will be presenting this lecture to you. The term memory is in reference to the process by which we encode, store, and retrieve information. Memory is not a passive recording system like a video camera. Instead, it is very active and it is reconstructive. This idea is very important in the field of psychology and in general in medicine, especially when we think about patient histories, eyewitness accounts, and even our own learning as medical students, physicians, and different fields of medicine. So the lecture will introduce core concepts that explain how memory works, why it sometimes fails, and how it can be influenced. So we will cover several key themes in this lecture. The first theme, we'll look at how memory reconstructs the past rather than simply replaying it. Then we'll briefly discuss how suggestion can alter memory. After that, we'll explore how memory is measured and the main models of memory, especially the three-box model. Finally, we'll talk about how we remember, why we forget, and briefly touch on autobiographical memory. These concepts are foundational and will reappear later when you study psychiatry and neurology. Memory is not an exact copy of past events. It is rather reconstructed each time we recall past events. This reconstruction can be influenced by several factors: beliefs, emotions, and new information we receive after the initial event. Understanding this is crucial in clinical settings. For example, when patients recall symptoms, trauma, or life events, what they remember may feel completely real to them, even if it is not really very accurate. Memory is selective, which means we do not store every detail of an experience. When we retrieve a memory, we are not replaying a videotape. Instead, the brain fills in the gaps using inference. Importantly, we are often unaware that we are making these inferences. One key concept here is source amnesia, which is the inability to distinguish between what we actually experienced and what we later heard or were told about that event. Confabulation refers to remembering events that never actually happened, or confusing someone else's experience with your own. This is not lying. The person genuinely believes the memory is real. Confabulation is more likely when an event has been thought about repeatedly, is easy to imagine, contains many details, or when emotional reactions are emphasized over factual accuracy. This has important implications in psychiatry and in forensic settings. Memory can be strongly influenced by suggestion. This is especially relevant in legal contexts, such as eyewitness testimony, and in vulnerable populations like children suggestive questioning can alter what people believe they remember. As future physicians, it is important to ask neutral, non-leading questions when taking histories. Research has shown that young children are particularly susceptible to suggestion. While most children aged 4 to 6 tend not to agree that false events occurred, a significant proportion of 3-year-olds may say yes. When investigators use highly suggestive techniques, even older children may report events that never happened. Social pressure plays a major role here, which is why careful interviewing techniques are essential. Hypnosis. Hypnosis involves suggesting changes in perception, sensation, or memory while the subject cooperates. However, memory under hypnosis is highly unreliable. Errors and false memories, also called pseudo-memories, are very common. Because of this, the American Psychiatric Association opposes the use of hypnosis-based testimony in courts, and most legal systems do not accept it. To study memory scientifically, psychologists have developed different ways to measure it and different models to explain how it works. In the next slides, we'll look at how memory is measured and then focus on one of the most influential models, the 3-box model of memory. Memory can be divided into explicit and implicit memory. Explicit memory involves conscious, intentional recall, such as remembering facts for the exam. Implicit memory operates without conscious awareness and is reflected in performances such as skills or priming effects. Both types are important in everyday functioning and in clinical practice. Explicit memory can be tested using recall and recognition. Recall requires retrieving information without cues, such as answering an essay question. Recognition involves identifying previously learned material, such as in multiple choice questions. Recognition is generally easier than recall, which is why exams often use a mix of both. Implicit memory is assessed indirectly. One method is priming, where prior exposure to information affects performance on a later task without conscious awareness. Another method is relearning, which measures how much faster material is learned the second time compared to the first time. These methods show that memory can exist even when we are not consciously aware of it. The 3-box model divides memory into sensory memory, short-term memory, and long-term memory. Information flows through these stages, although not all information makes it to long-term storage. This model helps us understand both normal memory function and memory disorders. Sensory memory briefly holds very accurate representations of sensory information, such as visual or auditory input. It lasts only fractions of a second. Pattern recognition occurs when this sensory input is matched with information already stored in long-term memory, allowing us to recognize what we are seeing or hearing. Short-term memory has a limited capacity and holds information for brief periods, usually seconds. It is also the workspace where information from long-term memory is temporarily held for use. Chunking helps overcome capacity limits by grouping information into meaningful units, which is highly relevant for studying medicine. Studies show that experts remember information not because they have better short-term memory, but because they organize information into meaningful chunks. For example, a chess expert can remember realistic board positions far better than a beginner. This principle applies to learning clinical patterns and diagnoses. Long-term memory includes procedural and declarative memory. Procedural memory involves skills or knowing how, such as riding a bicycle. Declarative memory involves facts and events or knowing that. Declarative memory is further divided into semantic memory, which is general knowledge, and episodic memory, which is personal experience. The serial position effect describes the tendency to remember the first and last items on a list better than those in the middle. The early items benefit from rehearsal, while the last items are still in short-term memory. This effect has practical implications for studying and for structuring lectures and presentations. Remembering depends heavily on effective encoding. Techniques such as rehearsal and mnemonics help strengthen memory. The way information is encoded determines how easily it can be retrieved later, which is why understanding learning strategies is important for medical education. Maintenance rehearsal involves simple repetition and is useful for short-term retention. Elaborative rehearsal is more effective for long-term memory because it links new information to existing knowledge and adds meaning. This is why understanding concepts is more effective than rote memorization. Forgetting can occur for several reasons, including decay, interference, lack of retrieval cues, and psychological factors. Forgetting is not always a failure. It can also help reduce overload and allow us to function efficiently. Decay theory suggests that memory fades over time if it is not assessed or accessed, especially in short-term memory. Ebbinghaus demonstrated that forgetting is rapid initially and then slows down. This explains why regular review is essential for long-term learning. Interference occurs when memories compete with each other. Retroactive interference happens when new learning disrupts old memories, while proactive interference occurs when older memories interfere with new learning. Both are common during intensive studying, such as in medical school. Sometimes information is stored but cannot be retrieved due to missing cues. State-dependent memory refers to better recall when the internal state at retrieval matches the state during encoding. This has implications for learning environments and clinical contexts. Psychogenic amnesia involves memory loss due to psychological rather than organic causes, often related to trauma or stress. It is an important concept in psychiatry and must be distinguished from neurological causes of amnesia. Autobiographical memory refers to memories of our own lives. Childhood amnesia describes the inability to remember events from the first 2 to 3 years of life. This is likely due to factors such as an undeveloped sense of self, limited encoding abilities, and different ways of understanding the world. Self-awareness involves observing one's own thoughts, emotions, and actions from a neutral perspective. It is not the same as being self-critical or self-conscious. Self-awareness plays an important role in autobiographical memory and psychological well-being. Autobiographical memory is not just a collection of facts. It is organized as a narrative. We naturally turn our life experiences into stories with a beginning, middle, and an end. These narratives help us create a sense of identity and continuity over time. However, because stories are shaped by meaning and emotion, they are also subject to distortion. This explains why different people can remember the same shared event in very different ways. When we recall autobiographical memories, we often focus on what the event means to us rather than on exact details. Emotional intensity, personal significance, and repetition through retelling all strengthen these emotions or these memories. At the same time, each retelling can slightly change the memory. This is clinically relevant when patients repeatedly recount traumatic or significant life events. Emotion plays a powerful role in memory. Highly emotional events are often remembered more vividly, but not necessarily more accurately. Stress hormones can enhance memory for central details while impairing memory for peripheral details. This is important in understanding trauma-related memories and conditions such as PTSD, post-traumatic stress disorder. Autobiographical memory changes across the lifespan. Early childhood memories are limited due to childhood amnesia, while memories from adolescence and early adulthood are often overrepresented, a phenomenon known as the reminiscence bump. Aging can affect retrieval efficiency, but well-established autobiographical memories are often preserved. In clinical practice, autobiographical memory is closely linked to mood and identity. In depression, memories tend to be overgeneral and negatively biased. In PTSD, post-traumatic stress disorder, memories may be intrusive and fragmented. Understanding these patterns helps clinicians interpret patient narratives more accurately. To summarize, memory is reconstructive, not reproductive. It is influenced by suggestion, emotion, and context. Memory systems include sensory, short-term, and long-term memory, and forgetting occurs through several mechanisms. Appreciating how memory works will help you both as learners and as future clinicians. Memory is central to human experience and to medical practice. Whether you are taking a patient history, studying for an exam, or reflecting on your own experiences, understanding memory will improve accuracy, empathy, and effectiveness. Keep in mind that confidence in a memory does not always mean it is correct. Thank you.